লাউসে কিছু কয় না কে?
আমাদের কথা লাউসে আমাদের কথা শুনে পাগল হয়ে গেছে।
第二节有课，所以跑不过来。
Hello. Hello. Can you hear me now? Hello. Okay, we begin together. Okay. Okay, the first one, 侯赛德. Second, 6 to number 10. This one. Six to 1-0. Hello. Okay, maybe send. Next.
I'm
here.
here. Look.
Okay. Next, Zembe. 19. Zembe. Hello，任北。11. Hello, this one. 孟加拉国，孟加拉国是几点？Night. Yeah. 11. Hello. Okay, 11 present. Next. 18. Hello, this one. 18.
Yes, 老师。
Okay. Next, 伊利 08.
旁边
Next, 法西莫 14. This one. 高沙
Present
13.
teacher. Present teacher.
Okay. 09. Hello, this one. Zero 09. Okay, maybe absent. Sabater 11. Hello, 11.
Present.
Okay. 07. 7. Number 7. Hello, 7. 20. 1220. Hello, this one.
I'm present, miss.
Okay. Next, 07.
Present, miss.
Okay. 艾特 06. Hello, 06. 06. They're not here. 1206. 1206. Okay, present. Next, number 10. Hello,
Present
number
teacher.
10.
Present.
Okay. 04.
Present teacher.
Okay.
Present.
Okay, 05. Hello.
Present 老师，present 老师。
Okay. 华明 03.
Present.
Okay. 12. Number 12.
Present.
Okay.
Miss, I'm 6206.
Su Wen. Okay, you have missed your order, right? Okay, maybe for the same time. Su Wen. 05. Su Wen. Okay, absent. 蕾蕾.
老师。
Okay. 艾莫斯 here. 16.
Present.
Hello.
Present.
15.
Here, miss.
Hello. Okay, 02. This one,
Present,
02. Okay, next, 03.
好，老师。
Teacher, I am
Okay.
here. 205.
You missed your turn next time. Okay, for the second time.
I'm here, teacher.
04.
I'm here, teacher.
Okay. 08. This one. Hello, 08. Next. 1201. Hello, this one. Hello, this boy. 1201.
Yeah, I'm here. 老师，I'm here.
Okay, next time, quickly, okay? Present. 09. Hello, 09. Okay, absent. 12.
Present teacher.
Okay. 基朗不在，于连不在。Okay. Now we check it. This one. 6210. Hello, 6210. Hello, 6210. Okay, absent. Next. 镇北 1219 Hello 正北 here this one 09 1209 Hello this one okay not here next 07 Hello this one 07 next 艾特
I'm here, miss.
Okay. Next, this Âu Su Wei.
I'm here. I'm here,
Okay.
ma'am.
Okay. Next, 08. This one. Hello, 08. Okay, not here. This one 09 6209. Hello. Okay, present.
Present teacher.
Okay. Now, this is not here. So we end out the call and then begin our class. And I won't change it.
Laoshi, I'm here 209. Can you please
09.
give my present? 209. My name is Tufail MD.
I already closed this website.
Oh.
Okay.
Oh,
So next time come here earlier. Okay.
okay, ma'am.
Okay. Okay, last time we have learned a little about derivative, right? We have learned the tangent line and the instantaneous speed. Here. Okay, I hope you remember how to calculate the slope of a curve, the curve like this. I hope you remember the definition of the tangent line. This means the tangent line at P. The tangent line at P is the limiting position of the second line. This means as when Q approaches P and Q along this curve, we have this. Maybe I have this like this one here, like this. This line is called a tangent line. And if we want to find the equation of the tangent line, we must calculate the slope, right? The slope. And so we first calculate the slope of second line. We have known 2 points. We have known the coordinates. One is C, FC. The other is C plus H, FC plus H. So we calculate the slope of the second line. And by the definition, we have the tangent line is the limiting position. So we give the slope of the tangent line is the limit. This is H approaches 0 and second line. This means the slope of the second line. And in from this, we give this definition of the tangent line. This means we should know how to calculate this limit. Okay, or provided this limit exists. This means not infinity or negative infinity. Then we have tangent. Okay, and last time we have already calculated example 1. This is y is f sphere at 2, 4. We calculate the slope right? Slope, this is 4. Do you remember? Right? Slope is 4. And then we have this is another thing, another questions or another problems. This is the average velocity and instantaneous velocity. Okay, and we give, for example, you drive an automobile from your dormitory to our classroom, and you take 2 hours, and you have take this is 80 miles. So we can calculate the average velocity. So this is 80 miles over the hour is 2, so it's 40, right? This is the length or the distance, and here this is the time you have spent is 2 hours. So the velocity, the average velocity is 40, and so this means average velocity is the distance from the first operation to the second operation divided by the elapsed time. But during our trip, we know during our trip, our speed is not average velocity, right? Now, for example, the speedometer reading was often different from 40. Maybe you drive a car, you can see the speed is not 40. So we want to calculate the speed. This is not average speed. And at the start, this means it registered 0 because you haven't moved. So the distance is 0, so the speed is 0. And it goes as high as 57. And then at the end, you also stop. You have go to the second operation. So it fell back to 0 again. It's the speed from at the beginning is 0 and at the end is also 0. And just what does the speedometer measure? Okay, certainly we know it's not average velocity. Okay. So, for example, we'll give a more precise example of an object P. This is a P. This is another. For example, P here. This is P for 16 t square feet in t seconds. Thus, it first 16 feet in the first second, and 64 feet during the first 2 seconds, because we know this is 16 to square. During the first 2 seconds, this means when t is 2, we have this 16 times 2 square. So we have this is 64 feet. So it for faster and faster as time goes on. Here, figure 9, they give the curve of the distance traveled as a function of time. This means if we write s is equal to 16 t square, this is the curve of this equation, 16 t square. And then during the second, this is when time, the time is from 1 to 2. Now t fair, when the distance s is 16 t square. So when we consider the interval, it's from t1 and to t2. So we can calculate it. Fair is 16 times when t is 2, the 2 square, minus 16 times 1 square. We calculate is 48 feet. And it takes from time from 1 to 2. So we have spent 1 second, right? 1 second. So the average velocity we write is VAVG. Is the distance over this is the time we have spent. So the distance is 48 over 1, so it's 48 feet per second. But during the time interval from t is 1 to t is 1.5, and we also want to calculate the average velocity, right? The average velocity is the distance between this is 16 times when t is 1.5 minus 16 times 1 square over we have spent 0.5 seconds, right? So we calculate the average speed is 40, and the first one is 48. And this is another situation when t, we calculate the time intervals from 1 to 1.1, or we calculate from 1 to 1.01. And we calculate the respective average velocities to be, the first is 66.6. This is 62.16. So we can say during this time, the average velocity is 40, right? Velocity is 40. And so, but we want to calculate here. We want to calculate for example, the average, the velocity at t is 1, or we want to find the velocity at the point t is 2, or t is 3, or t is 3. We only have the result here, this one. We only have during the second. This means the time interval from 1 to 2, we have the velocity is 48. The time from 1 to 1.5, the average velocity is 40. And the next is 66.6, 62.16. But if we want to find here, it's not during this time, it's not during, this is during 1 to 1.5. But if we want to find when t is 1.5, so how to calculate this velocity? Okay, this is unknown. We don't know how to calculate a. Okay, and then how to solve it? You know, the shorter the time interval is, the better we can approximate the instantaneous velocity. Okay. This means the time interval is 1.5. If we want to calculate when t is 1, this one, so we know if we can approximate, this means this not equal, approximate it by average velocity. Okay, it's not the same. But if we choose the interval like this, it's 1, this 1.4. Okay, we can also calculate V1 by approximating it, right, in the time interval. So we can say when the time interval is shorter, here, for example, this 1.4, this 1.3, or from 1 to 1.01. 01, for example, consider this interval. From 1, I just okay, 1 point, like this one. I take this one here. From 1 to 1.01, we know the interval, this interval, time interval is shorter and shorter, right? So then we have the shorter the time interval is, the better with the approximate the instantaneous velocity at the instant t is 1. So we looking at numbers 48, 40, 33.6, and we might guess 32 feet per second to be the instantaneous velocity. That's 48 in the interval. 48 in the interval 1 to 2. Okay, this one we consider is from interval is 1 to 2. Okay, and 40 we consider it here. In this 40 is 1 to 1.5. This interval 1 to 1.5. And this one we consider in interval here. In interval 1 to 1.1. 1.1. And this one is we consider. Oh. This is 1.01. Of course, if you guess the speed at the point 1, at least at 1, maybe we can find this. We can guess 32 feet per second to be instantaneous velocity, right? This number is approximate the instantaneous velocity at time t. So this give us an idea how to calculate the instantaneous velocity. First, we should calculate the average velocity, right? And then we write P moves along a coordinate line so that its position and time t is given by. So if we write this is a position at time t, give ft. And at time c, here 1 is special, so we find a general number c at time c. And the object is fc, so this is the distance is c, fc. And at the nearby time, like this, at time 1, at time 1.01. So we can find another point is nearby time. We write is nearby time. We write is c plus h. Okay, c plus h. So we have the distance is fc plus h, right? And the time interval, this is c plus h, right? c plus h. And at c, you can find the distance is fc. At c plus h, you can find the fc plus h. So we can calculate the average velocity on this interval, right? The average velocity we write is VA average. VAVG is equal to FC plus H minus FC over with time. We spend H. This is the time, right? This is average velocity. We know it's not equal to the velocity at point C. We can write this about, right? It's about, we write the time at C is VC, okay? But how to find the accurate number of VC? How to find this one? How to find this one? You can guess how to find this one. This is just approximate VC. We can guess. Guess is not the accurate number, but I want to find this one is equal VC. This means VC is equal to which one? It's not. This just approximate. How to? You can see. This means the shorter the time intervals, the better we should approximate the instantaneous velocity. The shorter the time. This means the shorter the time interval. This time interval is shorter. This means how can we let this interval, shorter and shorter. This interval is C. Here this is C, C plus H. How to get it shorter and shorter? Yeah. How to get this interval shorter and shorter? Hello, students online. Please think about it. How to get this interval shorter and shorter? This time interval. Time interval is C, C plus H. How to make it shorter and shorter? Oh. Hello, students online. Are you listening to me? How to? It's just approximate the velocity at C, but it's not equal. How to get this is equal? The interval, the time interval, the shorter the time interval is, the better we should approximate the instantaneous velocity. Just get this interval, this C plus H. Maybe this means if we choose another point like this, right? So the interval is shorter, right? And we choose second point, interval is shorter, get shorter and shorter, right? This means the distance, this distance is approaching 0, right? So the distance is equal to, this means we let h approaches 0, right? When we let h approaches 0, the time interval gets shorter and shorter, right? So if we want to find this instantaneous velocity, we have here this is average velocity. We take limit, let h approaches 0. Okay. Here, this is h approaches 0. This h approaches 0. Here, this is average velocity, right? Average velocity. Okay, so we have this definition of instantaneous velocity. Okay, do you understand it? Okay, and then in the case, we can calculate. In the case when, this means when f is 16t squared, and the instantaneous velocity at t is 1. Now the case. Let me see. Does it work? Okay, okay. Okay. And see. Okay. And then we continue. We get this is here. Example 1. Here is the definition of instantaneous velocity. Now I just want you to okay, here. Okay. Now I delete the answer. And now by this definition, if ft is 16 t square, we want to find the instantaneous velocity at t is 1. Do you know how to calculate it?
We can't see your screen,
T is
teacher.
1. You can't see?
No,
We can't
okay.
see.
Okay, wait for I want to share. Here. Can you? I think it's okay.
Yes.
Okay. Now here ft is 16t square. Now we want to find the instantaneous velocity at t is 1 by this definition. Do you know how to calculate it? Here we know this is at time t. At time t. This is at time t is this is time c. This is t is 1. So this means we should replace c by 1, right? So we calculate at the time t. We write this is v is limit h approaches 0. This is average velocity is equal to limit here ft is 16 square t square. This h approaches 0, and the numerator is equal to, this is f, c is 1, so it's c plus h. Oh, c is 1. This is 1 plus h. C replaced by 1. 1 plus h minus fc is f1 over h, right? Over h. And then continue to calculate this limit. H approaches 0. Here, f1 plus h. This means t square replaced by 1 plus h square minus f1. The t is 1, f1 is 16, right? Minus 16 over h. Over h. And then we simplified it is limit h approaches 0. Yeah, 16, we know this is a constant. So maybe we write here in front 16. So it's limit 1 plus h square minus 1 over h. And now how to calculate this limit? How to calculate this limit? We can find when h approaches 0, here the denominator approaches 0, right? So this 0, the numerator when h approaches 0 is 1 minus 1, this is over 0. So it's 0 over 0 form, right? But this is not the answer, right? And now how to calculate it? Do you know this equality? A square minus b square is equal to, you know this? Is equal to a plus b, a minus b. Okay, so here this is 1 plus h square minus 1. 1 we can write is 1 square, right? So it's equal to a plus b is equal to 1 plus h plus 1, right? Times a minus b is 1 plus h minus 1, right? So we write is limit h approaches 0 is h plus 2 times this is h over h, right? You know, h approaches, this means h is near 0, but it's not 0. So h over h is 1, right? It's 1. So we can find this is equal to 16 times 0 plus 2, right? And it's equal to 32. Right? So by this definition, we can calculate the instantaneous at c is anyhow c. Okay. Hello. Any questions for this one? Hello, students online. Any questions? No. Okay. How about the other students? Any questions? Okay. If no, we continue. Okay. Here is one. Maybe. 又卡了。You can exam 4. You can try to finish exam 4. This is an object. This is in Chinese is 初始的. Intently at rest first due to gravity. Find its instantaneous velocity at t is 3.8 seconds. And at t is 5.4 seconds. Here we give the function, the gravity, the function ft is 16 t square. So you should calculate this one. just at 3.8. Try to finish this. Instantaneous. Yourself. You. Yeah, only you because. 于连去哪里了？睡过了哟。就是 he's sleeping. Because Thursday I think he's always sleeping. Hello students. Someone try to finish example 4 only at 3.8. Okay. Try to write the definition of the instantaneous velocity. Wow. Let me see. Oh. Okay. Or maybe you do it by yourself and just for me, I read it. Okay. Here is example. You write ft is 16t squared. Just calculate t is 3.8. Okay. What is? Okay. This is H is your first idea. Ft is 16 square t square. Ft is 16 t square. It's Ft t square. That's at this point only as 0.8. T is 3.8. No. See, this is 16t square. You got this square. No. Square here. Yeah. Minus. No. Why is just 16? You write C is equal to what? Yeah, right. 3.8. So it's 16 times 3.8 square. Right? This is 16 times 3.8 square. This T is we review the answer, okay? Here. This is we can first calculate the at time C. At time C, we find V is equal to this is FC plus H minus FC over H. Yeah, this means here Ft is Here, this means ft is 16t squared. So fc plus h is equal to 16c plus h squared, right? fc, here fc is 16c squared is not 16. Okay, so minus, okay, we simplified it is equal to 32c. This is I times c, this is c seconds. If we want to find the instantaneous velocity at c, this means c is, for the semester, c is 3.8. So we can find the v is equal to, this means c is 3.8 is 32 times 3.8. And we can also find v here, t is 5.4. So we can find it is 32 times 5.4. This means we can find any time, we can find the velocity at any time. Understand? Hello? I think Lily. Okay. Okay, we continue. Then, from these two problems, we have the definition of the derivative, right? We have seen the slope. We have calculated the slope of the tangent line and the instantaneous velocity. So maybe they have the same basic idea. So we can we choose the neutral name derivative and iterate two function and limit as one of the key words in calculus. So we have the definition of derivative. We have derivative of function f. This is another function. We have another function we write like this. This is f. And here we add this prime. This means prime. F prime. Read f prime. Whose value at any number here, at any number x is equal to f prime x, we write is equal to here, just like f x plus h minus fx over h. The limit h approaches 0. Okay, so we can compare the definition of the instantaneous velocity. We write instantaneous velocity is equal to limit h approaches 0 is equal to limit h approaches 0. This is f, right? This is t at time t. So t plus h minus ft. This is over h. So you can see we have we choose a neutral name is derivative. The ft here, ft is not only the distance. Okay, it's just a general function. It's just a function, right? It's just a function. So we have this f prime. I hope you know how to write this f prime x. Okay, f prime x. If this limit does exist, we say f is differentiable. This is differentiable at this point is x. Okay, and finding a derivative is called differentiation. This means differentiation, and the part of calculus associated with the derivatives is called differential calculus. Okay, for example, we should cover the answer and try by fx here. Fx is x cube. This is x cube plus 4x. Try to find f prime x. Maybe I should write f prime x here. Okay. By definition, we know f prime x f prime x is equal to limit h over to 0 fx plus h minus fx over h. Okay, here. Now we say fx is, here example 1, fx is x cubed plus 7x. Example 1. Find f prime x. Okay, try. Have a try. Solve this example of this example 8. Example 2. Yeah. I hope you can finish one during this time. Hello, students online. Please try to solve try to find f prime x. Okay. Uh, 3x squared plus 7. The answer is right, but what's your precise? How to calculate it? Your name is ID is 14. Can you share your answer? And just the final answer. You can take a picture to center. Okay. Oh, dx xn. X power n is n x 14. Hello, your Chinese name. I don't know your Chinese name. You have learned it before? 14. Okay, so if you remember this formula, then it's easy for you. In college, not in high school. Let me see, Lily. Oh, okay. Let me see, yeah. X cubed plus 7x plus 8. No. Fx plus h. This is x plus h cubed, not x cubed. Yes. First you should write fx plus h here and then fx. Okay, because here obviously this is wrong. So this leads to wrong answer. First you write fx plus h. You don't know how to calculate the value, how to calculate f, the value of f at x plus h. Yeah. Yes, but you write is x cubed. Oh, that's not that one. Let's see. Okay, we review the answer. Okay, review the answer here. F prime x, or how will understand it? F prime x is equal to fx plus h. X plus h is equal to x plus h cube plus 7x plus h minus this is x cube plus 7x, right? Plus 7x is equal to, here, calculate x plus h cube. I hope you can calculate it, right? And this is 7x minus plus 7h minus a cube minus 7x. So only this limit. Now we have this x plus h cube. This is equal to plus 7x plus 7h minus x cube minus 7x. Okay, this cancel, right? This cancel. So we have this is x plus h cube minus x cube plus 7h. You can simplify it. This one is equal to this one. Okay, this one. And average. Average, we can find h cancel. This h is h power 1, h power 2, h. So it's equal to 3x squared plus 3xh plus h squared plus 7. We let h approaches 0. This is 3x squared plus 7. So this is the answer. Where is h? H squared. This is h. Where is h squared? Here. This one. H squared. H cube over h is h squared. This h approaches 0. H approaches 0 because h approaches 0, so x squared is also x squared, right? So this is 3x squared. H approaches 0. This means 3x times 0. This is 0, right? H approaches 0. H squared is 0. Limit, right? So only 7 is 3x squared plus 7, right? Okay, any questions? Hello, any questions? If no, we continue. Okay. Okay, this one, I hope you can do by yourself. Next. This one, exam 3. I hope you can do one. I hope you can finish one perfectly. Yeah, exam 3. Another example. Example 3, this is fx is 1 over x and f prime x. right. Go on. Yeah, go on. Oh, forgot the limit. Yeah. H approaches 0, 0. Oh, no. Minus 1 over x squared, right? Okay. We do it together, okay? We do it together. Fx is 1 over x. Fx is 1 over x. Find f prime x. F prime x is equal to limit h approaches 0, fx plus h minus fx over h, right? So we can find is equal to h approaches 0. Fx plus h is 1 over x plus h minus 1 over x over h. Okay, and we simplified it. Limit h approaches 0. This is x plus h, x minus x plus h over h. Right? Right? Okay, and then go on. H approaches 0. X minus x minus h. Minus h is x squared plus xh times h. Here, x is near 0 but not 0. So cancel h over h is 1. Right? So it's equal to limit h approaches 0 minus 1 over x squared plus xh. Right? Here, h approaches 0. We can find x or h is 0 limit. So minus 1 is always minus 1. Minus 1 is like square. So this is our answer. Right? This is our answer. Any questions? Hello, students online, any questions? If no, we continue. Okay. Okay. We have many examples. Hello, this one. Example. Yeah. Because it's very important, so we will have to many exercise. Okay. Julian, if Julian is not here, maybe next time he will be confused. Right? Example. Try to do by yourself, okay? You should try to write f prime x. This fx is the square root of x. Oh, it's not equal. It's not equal. Huh? Oh, this is right. Yeah, this is wrong. Okay, maybe we can do it together. F prime x, right? F prime x is equal to limit h approaches 0, f x plus h minus f x over h. The right is equal to limit h approaches 0. Fx plus h is the square root of x plus h minus the square root of x over h. Right? But how to calculate the square root of x plus h minus the square root of x? Maybe we use absolute value. No? Do you know this? We know a minus b times a plus b is equal to a square minus b square, right? So we can multiply numerator and denominator both by this one. Right? Okay. So right is equal to limit h approaches 0. H approaches 0. A minus b times a plus b is a square minus b square. So it's equal to square root of x plus h square minus square root of x square over h x. Right? And then calculate is equal to limit h approaches 0, the square root square. So it's equal to x plus h minus x times h. Right? X minus x is 0, right? So h over h is 1. So it's equal to limit h approaches 0. This is the square root x plus h plus square root x is equal to h approaches 0, x plus h approaches x, right? So it's equal to square root x plus square root x is equal to 1 over, right? So this is the answer. Okay, next time if you see this, I hope you remember how to handle it. Okay, I'll deal with it. Example 4. Any questions for example 4? All steps understand? Okay. Continue. Okay, now we will give the equivalent forms for the derivative. There is nothing scared about use the literate in determining f prime c. Notice, for example, that we change h by c is right. Okay, it's just a symbol. P of 0, we write x plus here. We can also use as approaches 0. So among a radical change, but still just a change of notation may be understood by comparing figures 1 and 2. Note how x takes the place of x plus h, and so x minus c replace h. Here, this is the point C, FC. This is the point C plus H, FC plus H. And we have this definition, right? So FC plus H minus FC, the length, this length, right? And over H, here, this is C plus H. So this is H, right? This is H. And now, if I write here, this also the point CFC, but here I write this is XFX, and we know the length. This length should be FX minus FC, right? And here this is a point X coordinate is C. This X coordinate is X. So this distance is X minus C, right? So we can write is here minus C. We can write is also F prime C, right? Same length, the same. So we have another equivalent forms of the derivative. We write like this. F prime C is equal to limit here. H approaches 0. This means X approaches C, right? This is h approaches 0. This distance approaches 0. So this means x approaches c, right? X approaches c. So it's fx minus fc over x minus c. This is another definition, okay? I hope you also remember this one. Okay, and then, okay, example 5. This means use the last box result to find g prime c if gx is 2 over 3 x plus 3. Huh? Right here. Oh, right here. Limit h, oh, wrong. X approaches c. This means the box. Okay, this is a boxed result to find g prime c if gx is 2 over x plus 3. Example 5. Try. Maybe this is the last example. Yeah. Hello, student Sanglan. Hello, this is the last one. Try to finish it. Oh, let me see. Oh, yes, it's right. Isn't it? Okay, maybe I begin to explain. Okay, I begin to explain. Okay, maybe lady. Okay, okay, I explain. This is g prime c. We write is equal to limit x approaches c. The denominator is equal to 2 over x plus 3 minus 2 over c plus 3 over x minus c. Right? And then calculate. Limit x approaches c. This is equal to x plus 3, c plus 3. This is 2c plus 3 minus 2x plus 3 over x minus c. Right? And then I calculate the denominator, numerator. X plus 3, c plus 3. This is equal to 2c plus 6 minus 2x minus 6. Right? Okay, I write here. Limit x approaches c. This is x minus c. This is x plus 3, c plus 3. Okay, here is 2c minus x. right? Here, 660 to c minus x, right? And here, c minus x minus c. So we can write is equal to minus limit x approaches c is 2 x plus 3 times c plus 3. Right? This is minus. And x approaches c. So it's equal to minus 2 over x approaches c. So x with by substitution, x with replaced by c. Oh, this is c plus 3 square, right? So we get the answer. Hello, are you right? Let me see if you are right, if you understand it. Let me see. Okay. First, Lily. Okay, yeah, you're right. I'm leaving. This boy. Wow, right. You can see he's right clearly, right? You see, he's right clearly. It's beautiful. Okay, we can end our class because we don't have our break. Okay. Hello, bye-bye.
Goodbye, miss.
Bye-bye.
Goodbye.
Okay.
Jazakallah khair. Wait, it's mine.